Hello everybody, welcome back to Das Lab. Today we got a special unbagging of something that was donated to the channel for investigation and repair. It is a battery charger and starter, booster type of thing. And we got this from our buddy Radiation Rob there, and he said what was happening was it was shorting out and tripping off breakers and whatnot, so I'm not even going to plug it in, but it's missing a handle, and apparently people were using this as the handle. So right off the bat I'm looking in here at the supply and seeing some issues. So before we even plug this bad boy in, and I think he said it served him well over the years, but it's lived its life. So we'll just start taking it apart and see if we can see anything obvious, and then we will plug it in, there's all kinds of different technologies as far as battery chargers and whatnot go with this. And apparently you can actually use this to start a car, like its own booster pack. Not quite sure how you're doing that off of a 15 amp circuit breaker, but I guess we'll find out. Okay, I'll get these screws out and I'll come back and show you the big reveal. Okay, here's the last screw of 16, I think, and boy, oh yeah, a little bit of electronics in there. It's semi-smart, I guess, and yeah, there's the input cord. No smoke. Big honking transformer. Ground. I think the first thing I'm going to do is just re-terminate this power supply cable before I even plug it in. Ground's good. Some hot snot around there. What does it actually say here? So select voltage, so you can do 6 volt, 12 volts. Charge or start. Read warning on back and those inside the instruction manual. We've got battery type, so standard, conventional, or maintenance free and deep cycle. Charged, cables reversed, overload, 2 to 15 amp charge rate. Start, I guess if you're in start mode, and just good old power. What to see on the back here? Warning. Connect this guy's battery leads only after the charger is unplugged. So you always put the leads on first before you plug it in. Don't overcharge battery, do not smoke, using well ventilated air, do not expose to rain or conditions, and do not use the power cord as a handle. And then again en français. Input 2.7 amps, that's all it's taken. Oh, and 13 amps. I guess depending on which way you are. Output is 2 to 15 amps continuous, 100 amps at continuous 5 seconds. Maximum on, 100 seconds minimum off. Alright. So if I cut that one, goes there. That one goes there, and that one goes there. So I can't terminate that too easily. Okay, that's nice. The white goes to the black, and the black goes to there. And that is just... Okay, I got three things all going into there. So what I'm going to do is I'm going to terminate and splice. just cut this out and terminate and splice over here. I'll bring that through. And I'll use some crimps. Plan. Guess I'll be standing for this one. Okay, let's just reposition you a bit so you can see. And let me get in here. Deep into the supply cabinet. And we need some of those. And probably those and those. Okay, so let's just cut that off about there. I want to inspect too and see if there's anything actually broken there. So I don't know what would be shorting it out. Alrighty, so I've got these re-terminated and crimped, and I got my grommet back in. Safety first, you know. So what I do is I've got this power bar over here that I can turn on and off, and I tend to plug things into that, and it's, you know, it's easier to turn on and off than to plug in and out. So in case something goes cuckoo, sorry, you're all twisted down your feet here. So what have I got here? I'm gonna try to not touch anything. Again, no fuses. It looks pretty wonky, like the there's no real on-off. I'll put it on normal. I'll put it on 12 volt. I'm gonna put it on charge and 2 amp. And we will simply make sure that the leads are not connected. I do have batteries here I could check it up to, but I'm not really at that stage yet. So we'll put that in and... Whoa! Okay, no short circuit. I don't know if you can hear that. That's a nice 60 cycle hum there. Alright, so we've got some something happening here. We got start power. Let's see if the power light comes on. Yeah, we got the power light on. Hey, maybe we fixed it. Okay. Let's try the 15 amp part. I know there's no load on it. No trip. Nothing there. Right there. Oh, 6 volts, a little quieter. Try the start function. Again, make sure these aren't connected or anything. Okay. Alright. I'm unplugging this thing. It is unplugged. What's next? I guess I'm gonna make sure that these are good. Okay. I'm not even gonna bother taping those. I'm gonna put it back together and I'm gonna try charging the battery. So let me put it back together. Okay, so here's the test. We've got a battery, deep cycle marine battery, and we've got negative here and positive over here. We got no indication of reversed leads. I got a nice handle on here now. Okay, and you know what's missing? Oh, felt like it's missing some feet. Okay, so I'm going to put it on 12 volts, I'm going to put it on charge, I'm going to put it on 2 amps, and I've got it on deep cycle battery, and I'm plugging it in, and we'll see what happens. No explosions. Seems to be charging. Oh, and we blew the breaker! Ah, that's what he's talking about. So I had to leave it on long enough. Shoot. Well, that's funny. Now, fortunately, I just blew the breaker over there on that thing. I wonder if it took a second or two to cycle up and then click in. Wow, I thought this was going to be a quick one. Nope. All right, unplug that. Reset the breaker. I'm going to try this again unloaded. And see what happens. 2, 3, 4, 5, 6, 7, 8, 9. Okay. Huh. So after a period of time, it does trip the breaker. Wow. Oh, look at here. That's no good either. Okay, but that's not why the breaker's tripping. Well, I'm gonna have to think about this. Okay, so we power it up. It hums like a son of a gun for 10 seconds, and then it trips the breaker, which may be a safety feature of this. I have a feeling that the electronics in there is doing some sort of a diagnostic, and if it sees a fault, it basically, instead of just shutting itself off, leaving it plugged in, it takes out the breaker. Maybe not the safest thing in the world, but it might be like a crowbar effect. Surprised, you know what I am surprised at? There's no fuse holder on here. So I think it came with a fortune cookie, but there's not even a fuse on there, you know, and right off the bat, that should have been an alarm to me, saying if this isn't fused, okay, externally, and let's take it over, let's go see if there's a fuse inside. I'm thinking right now, gone, but let's take a look. Okay, so all I know is that under no load on the 2 amp setting, running for 10 seconds, this is hotter than a firecracker. Oh my God, that heat sink. So something, this is no longer a repair. This is a, why did it fail? And we're gonna get some nice switches and a meter and a bit of copper wire. But I think we're gonna leave that for another day. We're gonna go in and spend some time with the boys. Okay, I'll be back later. Okay, welcome back everybody. I'm not even sure where we left off. A couple weeks ago I was working on this battery charger. Thought we had it figured out, but turns out after about 10-15 seconds of running, it would trip the breaker. I decided at that point in time this is no longer a repair. This is a why did this fail? It was getting too hot. You know, this would be the type of thing you tend to leave alone for a while it's charging batteries. There's no fuse on it. There's, you know, if there's a problem and it's trying to trip the breaker in your house to do that, it means your lines are getting overheated, and it's just not a good thing. So we are doing this to it. Okay, we're just cutting that cord off. And because that end looks like that, I'm just getting rid of that too. I don't want to use that. These are too cheap to fool around and try to salvage something like that. I mean, nobody's a bigger scavenger than I am. There's some good wire here. Who knows? I'm going to keep that. But we're going to put all of our parts that we're going to scavenge out of this over in the side. But, you know, safety first, and it comes to practicality. Are you going to burn your house down? I have better battery chargers than this, and smarter. And took these cables off already. I don't know what I'm going to do with those. They're good, heavy duty, you know, 10 gauge wire, maybe something. So when you're trying to boost something, if I could connect these to a battery and trying to boost something, you're not spending all of your energy heating up the wires because they're nice and big. And you know, you wouldn't throw something like that. Who knows? So the job of this thing is to take 120 volts AC power, which is your sine wave, and convert it into 12 volts DC, or 6 volts. Meaning that it's not a sine wave anymore. At the very least, it's pulsed DC. So pulse DC. Somewhere in here should be a one-way valve that only allows the current to flow in one direction. That would be a diode or something like that. So what we're going to do is, I suspect that it's something on this plate that has shorted out, one of these big multi-pinned voltage regulators or whatever they are, or possibly something down inside of here. So we're going to take it apart, scrap it. I got some nice switches. I'm going to save those, maybe some nice lights, and we'll just start taking it apart and we'll recycle whatever we can. Okay, once I get to where I can start testing something, we will bring you back into the near region. So anytime I come up with something interesting, I'm going to just bring it to your attention. These switches, they had to hot glue gun them in. Okay, I just chipped that hot glue off there. Like, if that's your answer, I don't know. Like, I just don't know, because it's a nice switch, but you're building it so cheap that you gotta use a hot glue gun to hold it in. I don't know. Okay, this is cool, but it's scary cool. What this was like a sandwich held off with an insulating screw in here. And when I unscrewed this, these little pucks fell out. So it was 4 of these on one side in these little divots, and then sandwiched. I think I know what might have been the problem with this right off the bat. Sandwiched in between here. And these are our little check valves. These are diodes. Now they're doubled up. You should normally need 4. Well, we got 8, so maybe they're in parallel carrying the current. Buddy Boy, Radiation Rob, said that because the handle was off this, people had dropped this a number of times and it stopped working. I have a feeling there were also connections on here, okay, between here and here, and I have a feeling that that we probably just had a bad connection on one of these little things that's supposed to be sandwiched in there, like that. Here, I'll draw you a picture. Okay. We plug this into 120 volts AC. That's going to be our big sine wave. 120 volts. We want 12 volts out here. Now I'm exaggerating, and I know I'm going to get a lot of comments on this, but this big thing here, this transformer, can take the 120 volts input and step it down to 12 volts. It transforms. It's our gear reducer. The voltage goes down, the current can go way up, different things like that. So there's our transformer. Now, output of this transformer, if I just had one of these diodes, which is like a check valve, it only lets AC go in one direction. So obviously it goes in the direction of the arrow. So when this is going up, my output would go up like this and come back down. But when the output's going negative, when the current's trying to flow the other way, nothing would happen, and we'd end up getting that bottom part of that sine wave wouldn't be there. That would be a very crude rectifier. But because if you arrange a bunch of these in what's known as a bridge, instead of doing this, you can do something like this. You see how I did that? That's the magic of editing. This is called a full wave bridge rectification. This is half wave bridge. This is full wave. You end up getting this, looks like this now. Now there's a shift in it, but we don't count that. So you end up getting something that looks a little bit more like DC. And then you've got other pieces of crap in here that filter it and regulate it, and you can end up getting your 12 volts DC coming out of that rectifier. That's what these are. These are these little buggers right here, and because they probably can't carry all the current, you need bigger wires, so they just double them up. So what I'm going to do now is check. Come on, there's one more of you buggers around here. Is I'm going to check these. You can put a meter on here. They should only flow in one direction. So I've got a tester here. I'm making a couple assumptions here, but I got a tester here, and we're going to just see if this. Where's my little meter? Right there. See, diode check. Put that on there. Now these should only allow current to go through in one direction. And we'll turn our sound on so we can hear it. And if current flows, oh, doesn't work in sound mode. Okay, we just got to look to see if there's any sort of current flow. Is there anything on here that indicates positive and negative? Nope. So we'll just learn by trial. So I got good current flow there. Oh my God, and that way. Okay, it shouldn't be that way. We are on diode, and I'm on diode check. There's one that's working right. That works in one direction. Okay, so it takes 0.5 volts to bias it, they call it, to get it kick-started so the electricity can flow through. And then when I switch it around the other way, oops. Okay, so it looks like the green side is negative. Okay, and again, right, the first one off the bat, that should be, they call that punched through. It's a short circuit. All right, we know what the problem was. I don't feel so bad cutting the power cord off it. One of them is punched through. There's 8 to check. That one's good. That one's good. That one's good. That one's good. I'm just getting lucky here. Black. Overload. Green is negative. That one's good. Green is negative. That one's good. Okay, there. That's why this failed. Because one of the diodes, okay, to get more current through here, they had double diodes on each one. Okay, doesn't matter. One of these was a direct short circuit. That's going to give you some bastard shaped form of that. What the waveform would look like, I don't know, and I'm not willing to risk my scope or anything to hook it up to try to see what it would have looked like. So, bottom line is, bridge rectifier short-circuited, and that was probably causing this excessive hum in here, some sort of imbalance in the transformer. I mean, that was really loud and really hot. Now, battery chargers are loud and hot. Maybe that's just the way it worked, but I thought for a battery charger not under load, when I first turned it on, that was humming pretty good. I mean, you know, everybody likes a good hummer once in a while, but not if it's going to burn your house down. Now, some people say, oh, you could use that transformer for, well, put it in the comments because I'm probably throwing it out. This I'm keeping. These beautiful pieces of aluminum, you don't get something like that. It's thick. It's nice and thick, right? Put that in the parts pile. That's printed circuit board material. A couple capacitors on there. Who knows what the status is of that? That's garbage. Interesting diodes. There's no leads on them. I'm not even going to keep them. Garbage. 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 They're probably pretty cheap. I was looking for you. And I am keeping all the hardware. Okay, let me get this printed circuit board out and we'll just take a look at it. Okay. I'm not a businessman. And I understand people are trying to make a profit, but first of all, I would have thought maybe one of these, I'm going to assume there's no numbers on them, like nothing. That they were voltage regulators to try to get the voltage to a prescribed amount. When I look at this board, pretty good layout. I mean, a lot of resistors, don't know what those chips are, can't even recognize the numbers on them. Some LEDs for indication there. We had different statuses of charging. I'm not even going to bother trying to save those. Even these switches, I thought of them. Now there's something with a heat sink on it. That may that's a heat sink to help dissipate the heat. When I flip it over, I just think, okay, my God. Usually it's pretty crappy, almost like this is an afterthought. If you're throwing things in here on this side, it's saying, okay, you know, we can make this a bit better. But if you look at the soldering on here and the poor quality, you use flux, like an acid, to clean the surfaces that you want to bond together with your solder. It's acid. It erodes things. Why don't you clean it off afterwards? These are so full of flux. It's only a matter of time with humidity and whatnot that activates it, and that where you start to erode your pads. Like, not only is it a poor soldering job to begin with, some of these leads are questionable. But you know, you leave the acid on there, like it's not cleaned up properly afterwards. So this, I mean, you'd never find this in a, like a, I don't know. I guess you get what you pay for. It must have been on sale. Maybe there's our fuse. I think I found the fuse. What does they call this one? I think it's R1. That may very well have been a fusible link. They were expecting that to melt. Because what the hell else is it in there for? RMN. So, that's what you got. What have I gotten out of the scrap metal bin? I've gotten some nicest pieces of aluminum for the metal pile. A nice switch with connectors on there. Maybe pretty standard looking connector. So, you know, I may not keep these wires, but I probably will just in case. Actually, they click in there kind of nice. Seem like good switches that I could use for something down the road. Some nice standoffs. They are always handy for, you know, when you don't want your electronics to short out something. You just have it standing off. That's about it. The leads, a little bit of wire. The only thing salvageable out of this whole project. Well, there you go. Repair. I'm not even going to keep these diodes. Garbage. A repair turned into an investigation. Why did this fail? Because we lost some diodes in the bridge. I would have actually thought it would be bad contact from those aluminum plates. Anyhow, thanks for stopping by. You know, all kinds of different things to see down in the video playlists and whatnot. Put your comments down in the nether regions. I read them. I like them. Help make the channel a little bit better. Hit that like button. If you think you want to see more of this, subscribe. I'm not going anywhere for a while. I'll keep making these videos. But whatever you do, be safe. Have fun. Don't get any on you. See you next time, folks.